Hi, welcome to my channel, Math Made Easy with Laurel. In this video, we're going to talk about molarity. In the previous video, I talked about the concentration of a solution in terms of percent. In this video, we're going to talk about the concentration of solution expressed as molarity. Molarity is moles per liter. Now, before we proceed with this, just a little bit of background on molar mass and what a mole actually represents. So a mole is the amount of substance that contains as many atoms or other particles as there are atoms in 12 grams of pure carbon-12. You'll see the term molar mass or molecular weight used, and the unit that's used to measure molar mass is grams per mole of the substance. So molar mass of an element or a compound is the mass of a given chemical element or compound in grams divided by the amount of the substance in moles. That information is available on a periodic table for all of the individual atoms. When you have a compound, what you're going to do is you're going to add the atomic masses or the molar masses of all of the atoms of that compound. Let's take a look at an example. If we're asked to find the molar mass of sodium chloride, we're going to find the molar mass of each atom in that compound. So sodium chloride is one atom of sodium and one of chlorine. So we look up on our periodic table, sodium is 22.990 grams per mole, and the molar mass of chlorine is 35.45 grams per mole. So in total, it's 58.443 grams per mole. So a very common unit of expressing concentration of solutions is molarity. It's also called molar, and it represents the concentration of that solution in moles per liter. So that means moles of the solute in 1 liter of solution. You might see a capital M used as well, and when you see that, it means moles per liter. So let's take a look at some examples where we're using the molar mass and either expressing our concentration in moles per liter, or if it's given in moles per liter, expressing it in another unit. The sodium chloride solution has a concentration of 15 moles per liter. Express this concentration as milligrams per deciliter. So we're given the concentration as molarity. We know the molar mass for sodium chloride is 58.443 grams per mole. So what we're going to do is use that information to convert moles per liter to grams per liter, and then we'll convert to milligrams per deciliter. Let's start off with 15 moles per liter and change it to grams per liter using molar mass. We're going to use a process called dimensional analysis, and the way that that's going to work is we're going to multiply by the molar mass, making sure that if we want to eliminate moles, and moles is in the numerator here, we put moles in the denominator, and grams will be in the numerator. So the moles will cancel and we'll be left with grams per liter. We know that 1 mole will have a mass of 58.443 grams. That will allow us to cancel moles, and we will have the concentration in grams per liter. We can calculate that, but let's continue our process of dimensional analysis to change grams to milligrams and to change per liter to per deciliter. So we can do it all in one fell swoop. To change from grams to milligrams, grams is in the numerator, so I'm going to put grams in the denominator, and I want to replace it with milligrams. You can either say that there is 1,000 milligrams in 1 gram, or if you use your table of metric prefixes, you can say 1 milligram is equivalent to 10 to the negative 3 grams. Either option will give you the same result. So now grams will cancel. Our concentration is now in milligrams per liter. We want it milligrams per deciliter, so we're going to convert from per liter to per deciliter. Liter is in the denominator, so we want to make sure liter is in the numerator so that it will cancel. And we want to replace it with deciliter. So in order to multiply by this fraction, the numerator and the denominator have to be equivalent. So we can do that one of two ways. We can either say 1 liter is equivalent to 10 deciliters, or if we use our table of metric prefixes, we can say 1 deciliter is equal to 10 to the negative 1 liters. Now liters will cancel, and we can do the calculation, and our answer will be in milligrams per deciliter. We're going to take 15, we're going to multiply by 58.443, we're going to multiply by 10 to the negative 1, we're going to divide by 1, divide by 10 to the negative 3, divide by 1, and the answer is 87,664.5 milligrams per deciliter, which you can then round off according to the rules of significant digits. The solution is the same concentration, it's just expressed in a different unit than it was originally. It was given in 15 moles per liter. This is what it's equivalent to in milligrams per deciliter. Let's take a look at some more examples. The next example says a solution of sodium hydroxide has a concentration of 2%. What is the molarity? In finding the molar mass of sodium hydroxide, we take 1 atom of sodium. Look in the periodic table, its molar mass is 22.990 grams per mole. 1 atom of oxygen is 15.999 grams of mole, and 1 atom of hydrogen, 1.008 grams per mole. Add all of those up and we get a total molar mass of 39.997 grams per mole. So the concentration we're starting with is 2%. In the previous video I talked about what 2% means. 2% means 2 grams of solute in 100 milliliters of solution. So we want to express this concentration as molarity, which is moles per liter. So we need to change from grams to moles. We're going to use our molar mass to do that. Now because we want to cancel grams, grams goes in the numerator, 1 mole will have a mass of 39.997 grams. Grams will now cancel and we will have our concentration in moles per milliliter. We want moles per liter, so we're going to change from per milliliter. Milliliters in the denominator, so in order to cancel it needs to go in the numerator, and we want to replace it with liters. 1 milliliter is equivalent to 10 to the negative 3 liters if you look up your table of metric prefixes, or 1 liter is equivalent to 1,000 milliliters. Both options will give you the correct answer. We're going to cancel milliliter. You can see the units left are moles per liter. So we're going to take 2, multiply by 1 times 1. We're going to divide by 100. We're going to divide by 39.997, and we're going to divide by 10 to the negative 3. When we do that calculation, we will get 0.5, and it's moles per liter, which we can leave as 0.5 moles per liter, or you may see it expressed as 0.5 capital M. That means moles per liter. So this solution has a concentration of 2%, and that concentration is also equivalent to 0.5 moles per liter, or 0.5 molar. Let's now take a look at some examples where we're finding the amount of solute required in grams to make a certain concentration expressed in molarity. The question asks, how many grams are required to make 500 milliliters of a 2.5 molar solution? A 2.5 molar solution means the concentration is 2.5 moles per liter. We need to change this to grams per liter, and in order to do that, we're going to use the molar mass. We want to change from moles to grams, so moles is in the numerator, put moles in the denominator. We know 1 mole is equivalent to 39.997 grams. Moles will cancel. When we do the calculation, we get a concentration of 99.925 grams per liter. Now we can find the amount of solute required to make 500 milliliters of this concentration solution. We're going to use proportion. Whenever you're finding solute or solution, I find it easiest to use direct proportion. So if we know we have 99.925 grams of solute in 1 liter of solution, we need to calculate how many grams will there be in 500 milliliters. Either change this to milliliters, 1,000 milliliters, or we change 500 milliliters to liters. 500 milliliters is 0.5 liters. So you can work in milliliters or liters, it won't matter, you'll get the same result. We're going to cross multiply, ignore our units. So x times 1 will equal 99.925 times 0.5. And I only round off at the very end. Follow your rules of significant digits. So we would need 50 grams of our solute. Let's do one last example. This question says, how many grams of sodium chloride are needed to make 400 milliliters of a solution with a concentration of 500 millimoles per liter? So first step, I'm going to deal with millimoles and change that to moles per liter. There are 1,000 millimoles in 1 mole, just like there are 1,000 milli whatever in whatever. So I'm just going to divide this by 1,000, and that's going to be 0.5 moles per liter. I need to change that to grams per liter, and I'm going to use the molar mass to do that. So 0.5 moles per liter. I'm going to multiply by the molar mass, 58.443 grams per 1 mole. Mole will cancel, and the concentration will be 29.2215 grams per liter. Now that I have it grams per liter, I can figure out how many grams of the solute I need, setting up a proportion. So I have 29.2215 grams of solute in 1 liter of solution. This time I'll change to milliliters. So that's 1 liter is equivalent to 1,000 milliliters. And I'm making a solution that is 400 milliliters in volume. So I want to know how many grams are required in 400 milliliters. So again, I could use liters, that would be 1 liter, and then that would be 0.4 liters, or I can use milliliters. You'll get exactly the same result. We're going to cross multiply. 1,000 times x will equal 29.2215 times 400. Divide both sides by 1,000. I didn't round off as I was doing calculations, but at the end, then you can round off following your rules for significant digits. So molarity is just another way of expressing concentration, and you can change it to another unit such as percents or grams per liter or milligrams per deciliter or whatever unit using the molar mass and the process of dimensional analysis. In the next video, I'm going to talk about another unit for solution concentration, and that's called normality. So see you then.